Hi guys, today we're discussing distance versus time, how to deal with these problems. In this case, we're going to discuss the second case. In this case, we graph distance versus time. Again, similar to the case before, but we are given the speed and one reference point. In the previous case, we were given a chart that described the motion of the object. In this case, we're given speed and a reference point. For example, let the speed be 2 meters per second, an object moving from the origin. When we say the object moves from the origin, we mean that when time is 0, x, the position, is 0. And we're given that the speed is 2 meters per second. So we're given the initial point and the speed. So what do we do with that? In this case, the first thing we need to do is calculate the equation of the moving object. So how do we do that? By definition, speed is delta x over delta t, meaning the change in x over the change in time. x2 minus x1 over t2 minus t1. We're told that the speed is 2 meters per second. When time is 0, x is 0. We said it was at the origin, moving from the origin. So this is where we get the information. Using this information, we put them into the formula and we get that the speed, which is 2 meters per second, will be x2 minus x, which is my 0, over t2 minus my 0. This will let me calculate other t's. I solve this equation and I get 2 meters per second is x2 over t2, and from here we get that x, in general, x is 2 meters per second times my time. That is my formula. Once I have the formula, I prepare a chart. Remember that in the chart, my time is measured in seconds and my position is measured in meters. So we said when time is 0, x is 0. The second, when my time is 1, if time is 1, then my formula is x is 2 meters per second times 1 second. I cancel the seconds and I get 2 meters. When time is 2, x is 2 meters per second times 2 seconds is 4 meters. When t is 3, x is 2 meters per second, the speed, times 3 seconds is 6 meters. And with these numbers, I am in the position of graphing the motion of the object. So I set up my my Cartesian coordinates and I determine my domain and my range. My domain, x, the horizontal values, t values, are from 0 to 3, and the range, the x values, are from 0 to 6. So I use this for my chart, and I graph them. This is time and this is position x. So I read my chart and I use those numbers to complete my graph. When time is 0, x is 0, so I start at the origin. When time is 1, my position is 2, I go there. When time is 2, my position is 4. And when time is 3, my position is 6. So this is the graph of my motion that describes the motion. And basically this finishes the exercise. So to review the exercise, let's review this again before we leave this session. We're graphing distance versus time, but in this particular case we're giving speed and one reference point. When the speed is 2 meters per second, for example, and an object is moving from the origin, we have that time is 0, that means the origin, x is 0, that means the origin. The speed is 2 meters per second. What do we do with that information? The first thing we do is we calculate the equation of the moving object. The equation is delta x over delta t, the speed, which is x2 minus x1 over t2 minus t1. The speed is 2, the origin time is 0, x is 0. I use this information to plug it into the equation. I put the 0 for x1 and I put the 0 for t1, and I'm left with x2 minus t2, the zeros don't count, is equal to 2, and I solve and I get the equation of the moving object is 2 meters times t, 2 meters per second. Using that chart, using that equation, now I calculate values. This is the most important step. I plug in and I give it values. I give the values 1, 2, and 3. Could be 2, 4, and 6. Could be any values from 0 to 10, for example. And I put them in the equation. X is 2 meters per second times 1 second, which cancels and it gives me 2. X is 2 meters per second times 2 seconds, cancel the seconds, it gives me 4 meters. X is 2 meters times 3 seconds, cancel the seconds, and I get 6 meters. With this information, with this chart, I go and I make the graph. And that's all for today, folks. Thank you.